Hey, today's daily math was a little bit different than what you normally do on Wednesday. I chose some questions that are going to be really important for you to understand how to work. You may see questions very similar or even just like this on your quiz Friday. So I hope that you really took your time to do your best work when you were going through these and working them on your own. And I hope that you really take the time to pay attention to this video to make sure that you understand everything that it's asking you to do. So we've talked a lot about factors lately. Factors are the numbers that multiply together to equal a product. So I'm finding all the factors of 39 first. So to find the factors of 39, I'm looking for whole numbers that multiply together to equal 39. I'm going to start with 1 and 39. I know 1 times itself is always a factor of any number. So I can check 1 and 39. The next number would be 2. If I look at 39, 9 is in the ones place. That's an odd number, so 2 is not going to be a factor. I'm going to move on to 3. Well, there's a couple ways I can check to see if 3 is going to be a factor. I can either see if 39 is a multiple of 3, if I can skip count by 3's to 39, or I can divide 39 by 3, and if I don't have a remainder, then I know that 39 is a factor. So let's do that since we've been practicing division. So I'm going to put 39 here. I'm dividing 39 by 3 to see if 3 is a factor. 3 divided by 3 is 1. I do not have any left over. So now I divide my ones. 9 divided by 3 is 3, and I do not have any left over. So 3 times 13 equals 39. So 3 is a factor, and 13 is a factor. Okay, I'm going to try and see if 4 is a factor. Well, I can't get 3 things into 4 equal groups. So I would move my 3 over here, and that gives me 39. Well, I know that 4 times 10 is 40, so 39 cannot have a factor of 4. I'm going to move on to 5. 5 is not going to be a factor of 39 because there's a 9 in the ones place instead of a 0 or 5. So I'm going to try 6. I know that 6 times 6 is 36. 6 times 7 is 42. So 39 will not be a factor of 6 or 7. I'm going to try 8. 8 times 5 equals 40. So that would not work. Okay. If I go to 9, I know that 9 times 4 is 36. 9 times 5 is 45. So 39 does not have a factor of 9. Check 10. Well, there's a 9 in the ones place and not a 0, so 10 is not a factor. Do 11. 11 times 3 is 33. 11 times 4 is 44, so that skips right over 39. 39 is not a factor. And go to 12. 12 times 3 is 36. 12 times 4 is 48. That skips right over 39, so that's not a factor. The next number I get to is 13, and we already have 13 listed. So I know that we found all the factors of 39. 39 has factors of 1, 3, 13, and 39. Let's move on to 57. I'm looking for the factors of 57. I know 1 times 57 equals 57. So I'll check those two. After 1, I come to 2. I have a 7 in the ones place. That's an odd number. So 2 is not going to be a factor of 57. Okay, I can check 3. 57 divided by 3. I can put 5 things into 3 equal groups one time. I would have 2 left. So I'll move my 2 over to the ones place. Then I have 27 things to put into 3 equal groups. And I know that 9 times 3 is 27, so I would not have any left over. So 3 times 19 equals 57. I'll check those two options. So we'll go ahead and write that down. 3 times 19 is 57. All right, so we need to see if 4 is going to be a factor of 57. I can divide to check that. 5 things could go into 4 groups one time. I would have 1 left over, so I'm regrouping that 1 to the ones place. 17 divided by 4 is 4. I would have 1 left over, so I have a remainder of 1. That tells me 4 is not going to be a factor. So I can move on to 5. I have 7 in the ones place. That's not a 0 or 5, so 5 is not a factor. So I can check 6. I know that 6 times 9 is 54. 6 times 10 is 60. So that skips right over 57. 6 is not going to be a factor. So I need to try 7. If I do 7 times 7, that equals 49. 7 times 8 is 56. 7 times 9 is 63. That skips over 57. That's not going to be a factor. We just did 7 times 8 is 56. That's 1 away. Eight times 8 is 64. That skips over 57, so 8's not going to be a factor. Okay. We said that 7 times 9 right here was 63. If I go back to 6 times 9, it's 54. We had that up here also, so that skips over 57. 9's not a factor. We know 10 won't be a factor because it does not end in a 0. If I do 11 times 5, that gets me 55. 11 times 6 is 66, so that's not going to work. I can move on to 12. We said earlier, that was in the last problem. Okay, so 12 times 4 is 48. 12 times 5 is 60. That skips right over 57. So we've gone all the way through to the 12s. We haven't found any more factors, so we can be pretty confident that we're finished. The only factors of 57 are 1 and 57 and 3 and 19. So there's 4 factors of 57 also. The next question asks you to round the number 53,649. First, we're going to round to the nearest hundred. So I'll look in my hundreds place. I have 6 hundreds. Look next door to my tens. There's a 4 in the tens place. That's below the midpoint. So 53,649 will round to 53,649. 600. And if I take that same number and I round to the nearest thousand, I have 53 thousandths. The 600 is above the midpoint, so it's going to round up to 54,000. And for the last one, we're rounding to the nearest 10 thousandths. I have 5 10,000ths. I'll look next door to the thousandths place value. 3 is below the midpoint, so it's going to stay at 50,000. All right. Next, we are dividing by multiples of 10. So first I have 100 divided by 10 equals 10. Next, I'm looking for the value of A. What number divided by 100 equals 10? Remember, we can also turn this around to a multiplication fact. 10 times 100 equals A. So I know 1 times 1 is going to be 1. And I have 1, 2, 3 zeros. So A will be equal to 1,000. I can also kind of think of the zeros as canceling each other out. So looking at this problem, I've got 2 zeros and 2 zeros that would cancel each other out. That leaves me with 10, which is the same thing that I have as my product. Okay, so B, 100,000 divided by what number is equal to 1,000? I can make it a multiplication problem. 1,000 times B equals 100,000. Well, I have 3 zeros, 3 zeros. 1 times 1 equals 1. So I'm going to need 2 more. B is going to be equal to 100. All right, then for C, we have 1 million divided by 100 equals C. So if I take these 2 zeros from 100 and I cancel out 2 zeros in 1 million, here's what I'm left with. A 1, because 1 divided by 1 is going to equal 1. And I have 4 zeros. So C is going to be equal to 10,000. Remember, it's all about counting your zeros. And next, number 4, we have a function table. We're going from gallons to quarts. So if I draw my function machine here, I'm looking for the rule that if I drop in 1, I would get out 4. So I know that 1 times 4 equals 4. Let's see if that works for this set. Let's see if it works for 5 and 20. If I drop in a 5 and I multiply 5 times 4, I would get 20 out. So that works. So let's see if we can find the value of A. What number would I need to drop in that if I multiplied times 4 when it went through the machine, I would get out 12? So the same thing as 12 divided by 4. And I know that A would be equal to 3 because 3 times 4 equals 12. Okay, so we'll go down and find the value of B now. If I drop in 7 and I multiply times 4, 7 times 4 is 28. So I would get 28 out. So this table is telling us 1 gallon is equal to 4 quarts. 3 gallons, A equal 3. 3 gallons is equal to 12 quarts. 5 gallons is equal to 20 quarts. And 7 gallons is equal to 28 quarts. Our rule tells us that it takes 4 quarts to make 1 gallon. Okay, so here in this next set of problems, we are converting gallons to quarts. We just found in our previous problem, let me get back to it, sorry. We just found that it takes 4 quarts to make 1 gallon. And they're also giving that to us. So 4 gallons equals how many quarts? Takes 4 quarts to make a gallon. So 4 gallons times 4 quarts. 4 times 4 is 16. So 4 gallons equals 16 quarts. A is equal to 16. The next problem, I have 8 quarts and I need to take it to gallons. So it takes 4 of those quarts to make 1 gallon. So this time I'll be going from the smaller unit to the larger. I'm going to divide. 8 divided by 4 equals 2. B is equal to 2. 8 quarts is 2 gallons. Alright, next I'm looking at this model to see which equivalent fractions are represented. Now remember, for fractions to be equivalent, they have to have the same size whole. And if I look at those two circles, those are both the same size. And then they'll have the same amount shaded. And I can look at that and see that that is true. So in this first graphic, I have 1, 2, 3 pieces shaded. So 3 will be my numerator. There's 4 pieces in the whole thing. So that fraction is 3/4. My second graphic, I have 1, 2, 3, 4, 5, 6 pieces shaded. There's 7, 8 pieces in the whole. So that fraction, the equivalent fractions represented are 3/4 is equal to 6/8. All right. Next, I'm looking to see which model correctly represents the problem. To add fractions, I have to make sure my denominator's the same, and it is. So I'm ready to add my numerators. 7 plus 8 equals 15. So 7/10 plus 8/10 is equal to 15/10, not 16/10. So option 1 is not correct. If I look at option 2, 7/10 plus 9/10. 7 plus 9 equals 16. So 7/10 plus 9/10 does equal 16/10. I'm going to look to see if my mixed number is correct. To make one whole, it would take 10/10. If I have 16/10, I would have 6/10 left over. So 1 and 6/10 is the correct mixed number. So now we just need to see if the model matches. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10/10, or one whole. In the bottom hole, I have 1, 2, 3, 4, 5, 6, 7 shaded. I should only have 6. So because I have an extra one shaded, I know that option 2 is not correct. Okay, so if I go down to option 3, I have 7/10 plus 9/10. 7 plus 9 equals 16, not 14. So option 3 is not correct. If I move on to option 4, 7/10 plus 9/10. 7 plus 9 is 16/10. We found up in option 2 that 16/10 is equal to 1 6/10. So we need to make sure that our model is shaded correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. There's one hole. And then 1, 2, 3, 4, 5, 6/10 in my second hole. So option 4 is the correct answer. Next, I'm going to go on to number 8. I have multiplication problem of a 2-digit number. So I'm going to multiply 42 times 88. I'm going to draw an area model. My longest side is going to be 88. I'm going to split that into expanded form. So 80 and 8. My short side is going to be 42. I'll split that into expanded form as well. 42. And now I'm ready to multiply. To find the area of this top section, I'm going to do length times width. My length is 80 times my width of 40. 8 times 4 is 32. Now I'd have 2 zeros. Find the area of the next section. I'm going to do length times width again. So my length is 8. My width is 40. I know that opposite sides have to have the same length. So 8 times 4 again is 32. This time I just have 1 zero. Next, I'm going to find the area of this section. I'm going to do the length. The length at the top is 80. Then I know this length has to be 80 as well. So length is 80 times the width of 2. 8 times 2 is 16. And I have 1 zero. Then for this last section, I'm doing length times width again. My length at the top was 8, so the bottom has to be 8. If the left side has a length of 2, then the right side has to have a length of 2 also. So I'll do 8 times 2, and that is 16. Now all I have to do is add these together. So I've got 3,200, 320, 160, and 16. If I add all those together, I have 6 ones. 0 plus 2 plus 6 plus 1 is 9. 2 plus 3 makes 5. 1 more is 6. And I have 3 thousands. So 3,696 is the correct answer. That's my product for 42 times 88. Next, I'm using the associative property to solve. The associative property says I can associate or group together anything that I want to when I multiply, and I will get the same answer. So we're only looking at the first line. I have A times 2 times 5 is equal to or the same as 3 times 2 times 5. So I can see that I'm missing the number 3 on the left side. I have 2 on both sides. I have 5 on both sides, so I need the 3. 3 is my missing number. So A is going to be equal to 3. Now I'm ready to solve. So the parentheses tell me over here on the left side that I need to multiply together 2 times 5. Those are the numbers I'm multiplying first. They did that for us already. They said 2 times 5 is equal to 10. So B is this 3 is just dropping down. B is going to be equal to 3 also. Don't let that confuse you. So remember, we're just doing step by step as we go down. I'm going to move over to the right side. The parentheses here tell me I need to multiply this first. So 3 times 2 equals 6. I'm dropping that 6 down here. My 5 stays. So C is going to be equal to 6. I'm ready to solve my next step now. On the left side, I'm doing 3 times 10. 3 times 10 is 30. On the right side, I'm doing 6 times 5. And 6 times 5 is 30 as well. So D equals 30. And that proves that it did not matter which numbers I grouped together to multiply first, that I still get the same product. All right, number 10 says to select the diagram and answer that matches the problem. The garden has 3 times as many tomatoes as carrots. If there are 60 tomatoes, how many carrots are there? So I have 3 times as many tomatoes as carrots, and there are 60 tomatoes. So 3 times what equals 60? I can turn that around into a division problem. 60 divided by 3 equals the number of carrots. And I know that 6 divided by 3 is going to be equal to 2. And I would have a 0 at the end. So there's going to be 20 carrots. So now I need to find which one of the models matches. So here in this first problem option, I have 60 divided by 3 equals 20. So that matches my number sentence that I wrote. But the problem is here it's showing that there's 60 carrots, or 3 groups of 6 carrots. Our problem here tells us that the 60 represents the tomatoes. So that's not a correct representation. If I look over at option 2, it starts with 40 and 2 groups, and that's not anywhere in our problem, so that's not a correct option. I'm going to move down to option 3. Option 3, I have 3 groups of 20 tomatoes, which would be 60. 60 divided by 3 equals 20, and it says there are 20 carrots. Option 3 is the correct answer. Okay, moving on to number 11. I'm looking to see which model is correctly representing the problem. I'm subtracting fractions in all 4 of these options, so I have to check to make sure my denominator is the same, and it is. 6 minus 2 equals 4, not 5. So 6/8 minus 2/8 is equal to 4/8, not 5/8. So let's move to option 2 and see if it's correct. My denominator is the same, so I'm ready to subtract. 6 minus 1 equals 5. So 6/8 minus 1/8 is equal to 5/8. That's correct. I'm going to check my model. 1, 2, 3, 4, 5, 6 pieces are shaded, so we're starting out with 6/8 because there are 8 pieces in the whole. You can see that there's cross hashes on the other on this first one. So it's showing that they're taking 1 away, and we're left with 1, 2, 3, 4, 5/8. So option 2 is the correct answer. Moving on to number 12. Which model best represents the answer to this problem? I have 1 4/5 plus another 1 4/5. So if I add my wholes together, 1 plus 1 is 2 wholes. 4/5 plus 4/5 is 8/5. So let's think about 8/5 for just a minute. To make a whole, another whole, it would take 5 fifth size pieces. So if I take 5 of those out, I would be left with 3/5. So I have 2 wholes plus 1 more whole is going to equal 3 wholes, and I have 3/5 left. So I'm looking for the option that shows 3 3/5. Option 1 has 1, 2, 3 holes and 2 fifth size pieces. So that one's not going to be correct. Option 2 has 1, 2, 3 holes and 1, 2, 3 fifths shaded. So this one's going to be our correct answer, option 2. Let's look at this. I'm going to shade as we add just to visualize this problem in another way. So I'm adding 1. I'm going to shade 1 hole. And 1, 2, 3, 4 fifths. I'm going to change colors. And I'm going to add another 1. I'm going to shade 1 hole here. And 4/5 more. 1, 2, 3, 4. So that just gives you another visual representation of why that would equal 3 holes and 3/5. On to the next one, and asks, what is the measurement of this angle? So they've got a circle for us there just for reference. They've drawn out these 2 rays, and they're asking, this little arc right here represents the part I'm measuring. I can see that makes a perfect corner. That's 90 degrees. It's a right angle. Next, we have the question. Brandy picked 476 flowers. She wants to make 9 bouquets with the same number of flowers in each. How many more should she pick so she doesn't have any extra? So let's start with what we know. We know she picked 476 flowers. That's the total she has. And she wants to make 9 bouquets, so that's the number of groups. And she wants to have the same number of flowers, so that we know that those have to be equal groups. So I'm going to do 476 divided by 9. So I'm going to set that problem up. 400, 7 tens, 6 ones, and I'm dividing into 9 equal groups. Well, I can't put 4 things in 9 equal groups, so I'm going to move my 400s. I'm going to regroup them to tens. So now I have 47 tens. I'm going to list my multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. And 9 times 9 is 81. Alright, so I'm looking to see what gets me as close as I can get to 47 without going over. Draw my little thinking bubble here. 9 times what gets me as close as I can get to 47 without going over? Well, 45 is the closest I can get, so that's going to be 9 times 5. So I can put 5 in each group, and I would have 2 left over, so I'm going to move those 2 extra over here to my ones. So I have 26 to divide into 9 equal groups. So I'm thinking 9 times what gets me as close as I can get to 26 without going over. If I look down here, 9 times 3 is 27, but that's too much. So the closest that I can get is 9 times 2, which is 18, and that leaves me 8. So she can make 52, she can put 52 flowers in each of her 9 bouquets, but then she has 8 remaining or extra. So let's check our problem here. It says how many more should she pick? So she doesn't have any extras. Well, if I have 8 extra and I've got 9 groups, how many more does she need? She needs 1 extra flower to make all 9 of her bouquets even. So the correct answer is 1 extra flower. Alright, and the last problem that we have, I'm looking to see which model best represents the answer to the problem 3/5 times 4. So I need 4 groups of 3/5. So here's 3/5. There's one group. I'm going to make another group of 3/5. There's 2/5 and 1/5 more. There's 2 groups of 2/5. If I get 3/5 more, there's 3 groups of 3/5, but I only have 2 more. So option 1 is not 3/5 times 4. Option 2, I can see right here, there's some that are crossed out, so I know option 2 is not going to be correct. Let's look at option 3. Here's 3/5. Let me change colors, that'll make it easier to see. 1/5, 2/5, another one makes 3/5. So there's my second group. Let's do 3/5 again. 1, 2, 3 fifth size pieces. And we're looking for our fourth group. 1/5, 2/5, 3/5. Option 3 is correct. Another way that I can solve that, I know that I've got fifth size pieces, so that's going to stay the same. 3 times 4 is 12. Yes. So that will equal 12 fifths. I can break that into a mixed number. It takes 5 fifths to make a whole. Another 5 fifths would be one more whole. That would make 10 fifths. And I would have 2 fifths left over. So 2 and 2 fifths. And that's exactly what I have. Option 3 is the correct answer. All right, that's it for today. Have a great rest of your day. See you tomorrow.